Hello, this is video for lesson 3 of my Glacial Geomorphology unit. If you haven't checked out the other videos, make sure you go to the intro video first so you can kind of understand what all these other videos are and how they interact with each other. So this is our third lesson in this unit. This would be what I had probably imagined during the middle of your second week teaching the Glacial Geomorphology unit. As far as things you've done beforehand, you've already worked on glacial geomorphologic features and terrain features, so your kettle holes, your prairie potholes, eskers and moraines and stuff like that. And then you've also introduced students to the idea of the water cycle, particularly with groundwater. That was the last lesson that we just completed. Obviously, what we've discussed in the other videos is the in-between each of these lessons. There's going to be about a couple days worth or 2 class periods worth of your own kind of supplementary lessons that you're going to be needing in order to bring up everybody else's prior knowledge based on what you get from your initial assessments. So let's just jump into lesson 3 here. So I've entitled this one Continuing the Search. The reason being is because students are going to really get to play around with some new technology that they probably never worked with before in this one. What we're going to be doing is developing further understanding of glacial terrain, being able to identify it, and then looking at it kind of in a holistic standpoint, and then having students come up with predictions about how they think this a given piece of terrain interacts with the water cycle because they have that background knowledge now in that. With this, they're going to be looking specifically at the Iowa Great Lakes region using both Google Earth and the Iowa State LiDAR imaging. As far as the NGSS practices from the lesson, check out the big unit plan document with the NGSS standards and NXA. Those will all be there, and you can figure out which ones kind of go with this lesson or you think would. As far as background info, students should obviously have done those past 2 lessons going over glacial geomorphology, terrain, and then the water cycle and some groundwater materials there. As far as the background info for you as a teacher, you should be familiar with how to work the LiDAR imaging, which is one of the things I'll show you in this video. As far as the materials needed, students are definitely going to be needing internet access, and then preferably if they can, like a computer. It's going to just work better for trying to take images off of the database and putting it over into a PowerPoint. With that, you also need, I recommend PowerPoint because it works better for inserting pictures and then having kind of captions on it, as opposed to you using like a Word document or Google Docs. Trying to put pictures in there can be a little hairy at times. So some kind of PowerPoint variant for students would be helpful. So as far as an introduction is concerned, we have this video on YouTube. It's just a real quick refresher on the different types of terrain and how it works, and then they're kind of looking at it. The students will be watching it to try and see what they can identify as certain pieces of terrain. And so it's quick. It's like 6 minutes. Just a thing to get the class together, give them that refresher. As far as the investigation goes, students are going to go and open up Google Earth so that they can see those aerial satellite images, and specifically around the Iowa Great Lakes region. If you want to do it in your own region, if you know for a fact that it's been glaciated, that could work great as well. But for the way I wrote it up, I was looking at Lake Okoboji in particular in that region. Have them look at the Google Earth, starting to try and find areas where they think it could be an example of glacial terrain. So there's tons of prairie potholes nearby, the southeast side of the lake, and then some of the other areas they might be able to recognize that they went on either the virtual tour or the physical tour, depending on which one you were able to do. Along with that, once they've found some sites that they think is an example of glacial terrain, you're going to have them open up this Iowa State database that has LiDAR imaging, and this is just kind of the instructions for it. So what I'll do right now is we'll go in and show you that real quick. So I have it hotkeyed right now. Let's see if it loads. All right, but it's the Iowa Geographic Map Server. I'm going to slide this over so it's in there. GISU. It's part of the Iowa State website from the university. So it is public. You can access it. So what we're going to do, this is what the homepage looks like. I just favorited it and hotkeyed one that it was the site that I liked. You're going to slide down to open a map layer. In here we have elevation maps. And from the elevation maps we go to shaded relief and then 1 meter LiDAR hill shade. That's what's going to give us this imaging. So it starts off, I need to slide it over again because the screen's only so big. It starts off just showing the entire state. You have all the counties. The area that we've really been looking at is up here in Dickinson, a little bit of Clay County, oops, and some of Osceola County as well. So you can click on it. Just click on Dickinson County. It'll center a little bit. In order to get it really centered where you want, you have a select a zoom level over here. This one's at 500 right now, so I'm going to drop down to about 100 meters per pixel. So that means every pixel on here is going to be 100 meters. So it's still really big bird's eye view. So we've refreshed the map. We still can see things from the county standpoint. So we're going to zoom in to probably, I'll do 20. Trying to speed up the time here. All right, so here we have Iowa Great Lakes. We got West Okoboji right here, East Okoboji. Got a little bit of Spirit. If you wanted to, you could zoom out or click on these arrows and it'll move you up to the next grid square you've got. But for right now, this will work great. What this is this is going to be able to, this is an imaging that can get through trees and other stuff, so it can really show you the topography of the land that you're looking at. So I'm sure this looks a lot bumpier than what you probably saw on Google Earth. For instance, if you were to get on Google Earth and look up the Iowa Lakeside Laboratory, it's going to probably, I think this is Little Miller's Bay right here, you'd be able to see just kind of the farm fields and the facilities itself. You wouldn't really see this topography because Google Earth really isn't designed for that. That's when you come over here. If you saw something, so for instance, there's a bunch of little ponds and lakes on this southeast side of the lakes, you could say, hey, I wonder what that is. I wonder if that counts as glacial terrain. You could open this up and you could look for some of those signs of the glaciation, kind of that knob and kettle topography that's very indicative of glaciated terrain. So what I'm going to do is have them look around, have them play with this. This is brand new technology for most of them, so they can look absolutely anywhere. If you're outside of the state of Iowa, see if your local universities or state departments will have anything that would work like this. If not, just do a case study of Iowa. And so I'm going to go back to the one that I have saved. When they want to look up a very specific area, so for instance, this is Frida Hafner Kettle Hole. The way I found this and zoomed right in on this is I went on Google Earth, looked up kind of the street address or the nearest roads to it. So it was 210th, and then I want to say this is 177th. So I knew that it was in the closest intersection was right there. So I just looked for it, and then sure enough, I found this big knob that had a prairie pothole cut out into it. And so now I can see that this is probably part of a larger came or even an esker, because you have it going quite a ways. This is also a gravel mine, so this is another example of how we know this could have been a came or an esker, because it had a lot of sand and dirt and small rocks in there that's indicative of that. Another thing that's kind of cool about this is you can see where the floodplain's been. This is the Little Sioux River right here. I know you probably haven't talked too much about that, or if you have, that's fantastic. You can really see where this river's been in its history. So right now we can see the current banks, but when this thing floods, we can see this is a huge, essentially a sandbar of just dirt and gravel and such that the river has gone around and hasn't been able to, doesn't look like it's really been able to go through it or over it, so it's gone around it a couple of times. So that's kind of cool, because that's just a hill. If you were out there, you probably drove right through it, that you might not have realized was part of this larger river floodplain. So really have students mess around and play around with this. Going back to the actual lesson plan itself, though, once they have an area that they've really started looking at and really like, have them identify or try and identify one of each type of glacial terrain. So like a prairie pothole or a kettle hole, an esker or a moraine. You can have them identify more, you can have them identify less. That's pretty much up to you. I think one of each for starters would be good, just so they can get an idea. Then we're going to be having them make a plate. So they're going to take a screenshot of the LiDAR imaging where they can kind of definitively say, hey, that's what I'm looking at. And then have them take a screenshot of the Google Earth so you can have both of them side by side. Put that in PowerPoint because you can add those images really easily. And then underneath, have them type up a caption that explains why they think that Frieder-Hafner kettle hole is a kettle hole. Obviously, it's in the name, but have them describe what led them to believe that, because that's them coming up with a reasoning, a piece of evidence right there, and explaining their thought process. And then they have them save these so that they can use them later on as we progress into the later lessons and assignments that we have planned out. They can share this. This might take a couple days because messing around with the LiDAR the first day, the students might just want to mess around and play with it, and that's totally fine. It's a new piece of tech that they're not familiar with. As far as negotiation and data analysis is concerned, though, students should make a note of the rough location of the features, and then discuss their findings with their classmates in small groups, or if you want to come together as a class and have people come up and show what they found, what they think it is, and share a little bit. And then, like a lot of the other lessons, if they come up with any ideas for follow-on investigations or questions, like I've said in the other videos, that's really going to help steer where this unit goes, is based on what they're asking about. As far as assessment's concerned, have them share their PowerPoints with you. If it's on Google, have them give you access to it, or have them email you a copy if it's just a hard PowerPoint via Microsoft. But then you can have them answer the following questions at the end of their PowerPoint. Just make a new slide since you're already going to be seeing them. The bit 2 that I came up with: how would water interact with one of your features? And then, for example, would it pool? Is the feature permeable? Describe how water would just work with that. And then, where does the water from this site most likely drain to? So Frieder-Hafner kettle hole, since it's surrounded by this glacial material, there's a high possibility that it's only groundwater fed, and so that it goes into the groundwater. Obviously, if it lands kind of on this top ridge here, it's probably going to pool and drain down to the Little Sioux River there. But for the most part, this is probably groundwater fed and seeps into groundwater again. So get them thinking about that, seeing how water interacts and what the nearest water source is to what they're finding. And then, as always, any student questions or feedback, because that's, again, going to help you shape the lessons. Just like in all the other lessons as well, we have our after-action review, class by class, day to day. Compare what's working well, what's not working well, what do you want to revise for the future, because that's only going to help build this lesson to what it should be. If you come up with anything, write it down for yourself, but if you would like, share it to this in a comment to this video so other people can take a look at it and really try and make these lessons the best they can be. So, with that, as far as your follow-on lessons, you can make this take more than 2 class periods. You can make it just take 1 class period. Building off of this, just keep reviewing those terms and those features with students, because that's going to help build up that knowledge, really help ingrain that, and get them thinking about how it interacts with other things. So, as far as follow-on lessons, the next one I have, we're just probably going to go right into lesson 4. This one I didn't really envision too much of your own follow-on lesson. If you come up with one, also put that in the comments so we can keep building this up to what it should be. Thanks for watching. Stay tuned for the next video.